Okay, let's go on to section 4. Which of the following substances is the best conductor of electricity when dissolved in water? That means it is an electrolyte. An electrolyte is 3 things: an acid, a base, or a salt. Period. End of story. Okay? If it is a salt, it is a metal and a nonmetal, or one of those is replaced with a polyatomic ion. So if you look at table E, what you will see, see this? See that? There you go. All we're looking for is acid, base, or salt. Which of the following substances is the poorest conductor of electricity? So in this case, I'm looking for a covalent, or another word for covalent is molecular. So I'm looking for a covalent or molecular compound. So 2 nonmetals. Basically, not an acid, not a base, not a salt. There we go. Which of the following molecules is subject to hydrogen bond attractions? So hydrogen bond is obviously between hydrogen, but is between N, O, or F. So hydrogen with C, no. Hydrogen with N doesn't have hydrogen, hydrogen with C. So there we go. Hydrogen with N, O, or F. Okay? Oops, turn the wrong way. All right. Next part. Which of the following is a network solid? Network solid is something that is covalent, typically, right? But it's special, and this question is rarely asked on the exam, okay, just as you know, just so you know. But if you look, here are our examples: diamond, sapphire, ruby, Al2O3, which is corundum, and quartz. So it's going to be this example, but again, this question, please don't worry about, okay? So kind of not too much to worry about there. All right, name this compound. All right, so Cu. Look at Cu. Oh, it has 2 charges, and I know it's a metal. So this is copper. I need a Roman numeral, and then do you see after I've got a bunch of atoms, which means I have to go to table E, and the name of NO3 negative is nitrate, and you see how it has a -1 charge. But I have 2 of them, so one of these is -1, so the total charge of the NO3s is -2. In order to balance that, I need +2. So copper, in this case, has to be +2. Write the formula for iron 3 sulfide. So iron 3 sulfite. So where do I go? SO3 -2. All right, so easiest thing to do is crisscross. Crisscross. So Fe, take the number from the charge, put it down here. And then if it was in table E, I have to write it in parentheses. And then take the number that was up here and bring it down. Which means I have 2 +3s, so that's +6. And I have 3 -2s, which is -6. And that balances. Okay, but we just don't write the charges like that. Name the compound. All right, so this is nitrogen, because this is covalent, molecular, and it is dioxide. Write the formula for, and we don't use this, system, so I'm going to give it to you differently. So it would have to be this, not written like this. So it would be PO2, phosphorus dioxide. Okay, so now I need to find the formula mass, gram formula mass of this, so I need to do some work. So I need to go to the periodic table, and I need to get the atomic mass starting, oops, didn't mean to do that, starting with copper. So 63.5, that's copper. I have 1 copper. Nitrogen is 14. How many do I have of nitrogen? 2. So 2 times 14. And then oxygen is 16. And how many do I have? 3 times 2 is 6. So 6 times 16. And then I'm going to need to add that all up. So let's do 63.5 plus parentheses 2 times 14 and parentheses plus 6 times 16 and parentheses equals 187.5 grams per mole. Using this formula mass, how many moles are there in 100 grams? So what I need is this formula. Moles is mass over gram formula mass. So moles is mass over GFM. If I have 100.0 grams over 187.5, so I do 100.0 divided by 187.5, and oops, did that wrong. 100. See, sometimes when you do the math, you're like, wait a second, it should be like round half, but not quite. Yeah, see, 0.53 moles. Now using it again, how many grams are there? So this time I have moles. So I have 2.5 moles equals whatever the mass is divided by 187.5. Remember, think about it over 1, cross multiply. So the grams is simply going to be multiplying these two things together. So 187.5 times 2.5. And we get 468.75 grams. Okay, empirical formula CH, molecular formula is this. Determine the molecular formula. All right, so first I need to find the mass of the empirical formula. So the atomic mass of carbon is 12, the atomic mass of hydrogen is 1, so the mass of the empirical formula is 13. Is 13 the same as this? No. So I take 26 divided by 13 is 2. It's twice as big. So instead of having CH, what I do is I multiply each subscript times 2. And I get this. And we could check it. 2 times 12 is 24. 2 times 1 is 2. And that does, in fact, equal 26. All right, what is the percent by mass of water in this? Okay, so again, I have to find the whole formula mass. Okay, so I have Ca, Cl, H, and O. Right, so let's look these all up. Ca, 40.1. Cl, 35.5. H, oops, 35.5. H is 1 and O is 16. How many calciums do I have? Just 1. How many chlorines do I have? 2. How many hydrogens? 2 times 2 is 4. How many oxygens do I have? 2 times 1. Okay, so now let's add all of this up. So I have 40.1 plus, I'll just do it this way, 35.5 plus 35.5. You see that's two 35.5s, right? Plus 1 times 4 is just 4. Plus 16 plus 16 equals So my total is 147.1 grams per mole. But I want to know the percent by mass of water. And this is the water, right? So how much of this mass is actually water? So 1 times 4 is 4. 16 times 2 is 32. So that is 36. So that's all I need first. Now I need this formula. Mass of part over mass of whole times 100. So the percent is part over whole times 100. The part is the 36. The whole is the whole thing times 100. So I do 36 divided by 147.1 equals times 100. And I get 24.5%. All right. If 2 grams of a hydrate are heated to a constant mass of 1.2 grams, what is the percent by mass of water in the hydrate? Okay, so I'm going to use the same formula. Percent equals part over whole times 100. Okay, so what is the whole thing? Well, that was the 2.00 grams. So what is the part? Well, if I started with this and I heated it, when I heat it, the water leaves. So here, if I start with 2 grams, as I'm heating it, the water is going to evaporate away, and I'm going to be left with everything but the water. So the part of the water is 2 minus 1.20, and then times 100. So that percent is, this is 0.8 divided by 2.00 times 100. So 0.8 divided by 2.00 times 100. 40%. And there we go. That is the end of section 4.